Week two. Today, I want to thank everybody who's here, who's been here, who's been going over the material and following along in the course. Because we got 10 weeks of this, and we're almost to the fun part. We're almost out of hardware. Hardware can be fun, but hardware is kind of hard to learn in a digital space because you guys can't put your hands on it. But at the moment, we just got to kind of get through this part of the course, and then once we're through hardware, then we're on to networking and a bunch of other things that are security. We've got some things coming up that are pretty interesting. Also, while you guys are here on Friday, I will be uploading a test to the syllabus, and I'll also send you guys a quick test so that you guys can know what knowledge is pertinent for right now, especially when it comes to the CompTIA A plus and the job market. So I'll put together like a 10-15 question test that will help you guys out, especially with all the information that we've been going over. It'll help you kind of narrow down your studying and, hopefully give you insight on things that you need to study more. So on day 3 of our course, today we're going to go over connection interfaces and devices. So throughout this course, we've been diving into hardware, and earlier this week and last week we went over different hardware components, and now we're gonna kind of break down the different connection types. And some connection types that we'll talk about today are going to be USB, Ethernet, Wi-Fi, Bluetooth, and a couple other different interfaces. And we'll get more familiar with what those are and how they are utilized today. So first, before we start talking about connections, we have to talk about input and output devices, because that is also another part of the course that we're going to cover. We're still covering hardware, so it's a little bit of mix of cables. It's a little mix of some computer parts that we didn't go over before, like the power supply and a couple other things. So in the context of the CompTIA A+, which mostly everybody in this course, if you're not going to get it, you are at least are studying for it. We're on the track right now where you guys are going to be able to understand a lot of the information that will be tested on in the CompTIA. So we'll talk about input devices first. Input devices are hardware components that allow users to provide information or commands to a computer system. They enable users to input data or initiate actions that the user can process. Examples of common input devices include your keyboard, your mouse, scanners. Keyboards and mouse are pretty self-explanatory. Microphones, webcams, gamepads, joysticks, things like that. What I will say is that some of these input devices can be input and output devices, and it can kind of get muddy sometimes. So make sure that you're taking the time to understand what the actual input devices are. They're things that provide information and or commands to a computer. So you're sending information to the computer.
Hey Aaron, are you supposed to be showing it on the screen? I know I got the PowerPoint, but you wanted to show on the screen?
Yeah,
it just says Zoom.
Are you guys not seeing it?
No,
it just says Zoom right there.
Oh, okay. So we're on the wrong screen. Thanks, guys, for calling that out. Let me move this to the other screen. Stop sharing that there. Lord, I'm glad I ain't had nothing crazy on that screen, boy. Let me see. All right. Now let's bring up this. All right. Can you guys see this?
It's just showing us now.
All right. Give me a second here. Come on, work with me, Zoom. All right, can you guys see the, move this out the way. All right, you can see the PowerPoint now, right?
No, still no screen record. It's not sharing your screen.
Okay.
Cool. So we got the slideshow. Let's see if we play the slideshow, if it's gonna. All right, now what are you guys seeing? You still seeing the
See the
slideshow?
PowerPoint?
All right, cool.
Yeah.
So let's pop this back to the beginning. All right, so that's cloud resources. These are just, we didn't really miss too much for the first couple slides. We just got the input and output slide right here. So take a look over that. Like we were saying before, the input devices are devices that you are gonna input commands to make the computer give you some sort of output. So diving into it, keyboard, mouse, touchscreen displays, scanners, microphones, all those are input devices. Output devices present information that's been processed. So monitors, speakers, voice communications, definitely all of those are outputs, audio, video, and other things. Let's see if I can mute. If I could have everybody please mute your mics. It's important to note some devices can serve both input and output functions. For example, a touchscreen can be both used for input, touching the screen, and output, displaying visual elements. Definitely keep a note of that because that's something that I'll definitely put on the quiz. Understand the distinction. Now we're going to hop into some of our ports, and I'll have some pictures of the ports a little bit later on in the presentation. But in the world of computer hardware, legacy ports, whenever you hear legacy, always think old. The legacy means old. So anytime you hear of a legacy system or a legacy application, it's something predated, before 2000 or, 2010. A lot of these companies are holding around a lot of old applications. So definitely keep that in mind. Legacy means old. So legacy ports refer to older connection interfaces that were commonly used in the past but have been largely phased out or replaced by more modern technologies. So the serial COM port, also known as the COM port, was used to connect devices such as modems, mice, and older printers. And it's kind of like a circular port. If you guys have seen it, I'll show you a picture later on in the slides. So it uses, and these are cables that you really don't see nowadays in the wild, like VGA ports and DVI ports. The only reason that you'll see them is if you're probably working with older monitors in an office somewhere as a technician. Most companies keep around a lot of older equipment, and that older equipment is supported by VGA ports. So VGA ports are a big one that you'll see out in the wild. The parallel port, so we're going to go a little bit more in depth. The parallel port, also known as the LPT port, was primarily used to connect printers and other peripherals. It transmitted data in parallel, following for faster data transfer compared to serial ports. However, with the advent of USB, the parallel port has become obsolete for most modern applications. So yeah, this is a parallel port right here. It's obsolete. The PS2 ports were used for connecting keyboards and mice to computers. This one is also with older systems. It's a legacy port. So yeah, it's not really that important. We don't really see this much anymore. The USB though is a port and a connector that we see widely used today. The USB Type-C is the current rendition of the USB-C that the USB that we're using today. USB A and B both kind of look the same. They look like the old Apple chargers, the end that would connect to the blocks. And you can see the diagrams right here of the different types of USBs. And the USB Micro A is obviously the USB Micro B. USB Micro B is the Android charger. So you can see the different chargers. You can identify the lightning cable as the iPhone charger. So these are the different types of serial buses. USB is a widely used interface for connecting various devices such as keyboards, mice, printers, external storage devices. Pretty much all these connections are interchangeable as long as the thing I always kind of equate it to is when you watch little kids or like when you see scientific experiments and they have monkeys fitting holes in the slots. Fitting different blocks in the slots. So there might be a slot for like a circle, and they fit a circular block in there, or a slot for like a triangle. That's pretty much connections. It is important to know which one is which for testing purposes. But once you get out in the world, it'll come naturally the more you use these things, and the more widely your experience get, and the more experience that you get. So these are the different types of USB, and there's a lot of them, but the ones that you kind of want to focus on are USB A, B, and C. For the most part, those are the ones that are most common today. USB Type A is a standard and most widely used USB connector. It's a flat rectangular connector found on most computers, laptops, and USB peripherals. And if we go back, you can kind of see that USB A right there. USB B have a square, connectors have a square or rectangular shape with bevel corners. And that's the one to the right, so we're basically going in order. USB-C is a small reversible connector that has gained popularity in recent years, and it's probably the most common one that you'll see today. Most things now, if you go to buy like a charger at the store, they have a USB-C connection instead of a USB-A connection. It has a symmetrical design, so it's an oval, which means it can be inserted into the device in either orientation. Well, symmetrical means that it's the same on either side, but it is actually the shape of an oval. If you go back and look, it's oval shape. USB, Mini B, these are just all kind of different connectors. If you want to go back and look, you can get more familiar with these, but it kind of goes through like the history of different USBs. The mouse is an input device, and that's if you don't know anything else about a mouse, just know that the mouse is an input device. Everybody knows what a mouse is, but I guess if we want to go further in depth with mice, you can. They have different connection types, so I guess that's the most interesting thing I can think of about a mouse. Is like some are connected with through wireless connections where there's a receiver and a transmitter in the mouse, where it's connecting radio frequencies or Bluetooth. So, but the main thing to know about a mouse is to know that this peripheral device, one, it's a peripheral device, and that two, it is an input device. And I'm kind of running through these fast because there is a lot of information that we got to cover on this last course, on this last section of this module. We're running through hardware, but definitely make sure that you guys go back and just look over these. And when I make this test, it's going to make you go back and look over a lot of this stuff, and that's really what it's made for. But just so that you guys can kind of catch the pertinent information, but definitely utilize these resources even after this this session that we're having today, because ultimately this 1 hour or 2 hours that we spend together a week isn't going to be enough to really bring you up to speed with what you need to know. You're going to have to put in a little bit more time on your own, whether that be 30 minutes today and 30 minutes tomorrow. Start small, and eventually, small things grow to big things. So just like you would practice any other talent, you got to practice this every day. A keyboard, another input peripheral device. The fundamentals input device used with computers and other electronic devices for entering text, commands, numbers. It is a set of typewriter-like keys arranged in a specific layout. We use the QWERTY layout, so QWERTY, we use that layout. And basically, back in the day when people had the layout that was alphabetical, it just wasn't ergonomic. And ergonomic means it wasn't like comfortable or easy to use for people. So we changed to this design a long time ago, but this is the new design, the QWERTY layout. And that's basically all QWERTY means is those are the letters that are together in the top left-hand corner. So when you start off the keyboard, basically from the top left, those are the first letters that you hit across the board. A KVM. So there are two different KVMs. There are KVM switches, which you'll have in your server room, and then there are KVMs. There are actual KVMs that allow you to use multiple computers. So KVM stands for keyboard, video, and mouse. And this allows you to use a single keyboard, mouse, and video input to be able to connect to multiple computers. You can simply push a button on a KVM or use software to be able to move from one computer to the other, all the same keyboard, mouse, and monitor. So you see, it's basically like a docking station for multiple computers. So when you go into like your server room, when you're working on your job, there's going to be a bunch of switches that are connected to a bunch of cables. That's whenever you look at some IT shit and you see a bunch of cables all over the place, they're usually in the data center or the server room, and the things that those cables are connected to are called switches. And what those switches do is they basically carry your data to over the network. So that's how your network, your infrastructure is configured with those switches, carrying your network data, so your internet from room to room. So all the Ethernet ports that are connected in your office are connected back to that one room on ports in that in the data center on the switches. And basically, whenever you want to do something to control like different interfaces, so you have your switches, you have your VPN, you have your firewall, different things that connect. You have different things that connect different devices. And so with those devices, hey, mute your mic, please. And so with different devices, you'll be able to connect it all with one. Let me see if I can mute this, man. Yeah, I'll have to figure out how I can mute this in the future. Might just look it up now. But anyway, so KVMs, and then we'll go over what a KVM switch is. So a KVM switch is the same thing as a device that allows users to switch control between multiple computers or servers. The KVM that we saw before was something a little bit smaller, a little bit more mobile, and this one, this KVM switch is the bigger one. This is what you'll actually see in your data center. So the thing on top is kind of what controls what device you're using, and the switches on the bottom are all your connections that you have for your mouse and your keyboard and your monitors. So this one you can see is fairly old because it has legacy ports, and the one at the top, it looks like it's legacy ports too. It has DVI. So IEEE, basically FireWire. FireWire is a high-speed serial bus interface technology developed by the Institute of Electrical and Electronic Engineers. It was initially introduced by Apple in the 1990s and later adopted as an industry standard. FireWire was designed to provide fast data transfer rates and support various devices, including audio, video equipment, external storage devices, and other peripherals. And as we dive into FireWire, you can look at like the high speed. It's known for high speed peer-to-peer connections. And back in the 90s, all of this was like, the blues, like the newest technology. This was the latest in technology. So hot swapping is basically when you have things that are running, and while the device is running, you can switch out different components of it. So like your server rack, so RAID, for instance. RAID is an example of, if you guys remember, we went over RAID. If you watched the video from Tuesday, RAID is an example of hot swapping. Like you can hot swap disks in a RAID setup. So if a disk fails and you need to swap it out with another newer drive, you can go ahead and swap it out with a new drive while the RAID configuration is still running. So you still have uptime. You still have access to data, even though you might have a piece that is faulty. That's what redundancy is. Redundancy is when something fails, it will fail over to something else that will remain active while you can swap out. And then hot swapping is just when you swap something out while that thing is running, while it still has power connected to it. Isochronous data transfer. FireWire supports isochronous data transfer, which enables real-time streaming of time-sensitive data such as audio and video. This ensures that data is transferred at a constant rate, providing smooth playback and synchronization. That's basically like, we'll get into UDP and TCP, and those are two different connection types in networking. UDP is what you use for streaming, and TCP is basically what you'll use for um, going over the internet and just browsing in general. UDP has a constant connection, just like asynchronous data transfer. Daisy chaining, FireWire was widely used in the early 2000s, but it isn't really used now. And we'll look at a FireWire cable right here in the input. So you probably haven't seen these cables in forever. You know, they're thick cables. They're like USB cables, but I personally haven't seen one of these in a long time. Ethernet. Your Ethernet cables are what basically connects your network together. So that's what carries the data from the routers to the switches to your device, and that's basically how it goes. It goes from router, patch panel, switch to your device, and that's basically how that's as basic as I can really get a network. But a network, when you have your internet service provider gives you a router, a modem that creates your internet, and what carries it is these Ethernet cords. And there's different Ethernet standards and different cable types, and we'll get into that now. So the different types of Ethernet connections, there's several types. Ethernet 10 base T, also known as twisted pair Ethernet or simply Ethernet. This is the most common type of Ethernet used today. It uses category 5E or high twisted pair cables and supports data transfer speeds of up to 10 megabits per second. It employs a star topology with devices connected to a central network switch or hub. Switch or hub is going to come up in our next week when we start talking about networking equipment. Your switch and your hub basically control traffic. Fast Ethernet, 100 base TX. Fast Ethernet is an improved version of Ethernet that supports higher data transfers. It uses category 5 or higher twisted pair cables and offers a speed of up to 100 megabits. Fast Ethernet is backwards compatible with standard Ethernet, allowing devices to communicate across different Ethernet types. Gigabit Ethernet, this is 1,000 base T. Gigabit Ethernet provides significantly faster data transfer compared to fast Ethernet. So as you can see, the higher the number, basically the faster the connection is. It uses category 5E or high twisted pairs and supports speeds of up to 1 gig, which is 10 times faster than fast Ethernet. Gigabit Ethernet is commonly used in modern networks for high speed and data transfer and multimedia streaming. So whenever you talk about high speed internet, you want to have at least 100 megabits or better. Most places they say they offer. So one thing about connection speeds when it comes to your ISP is they'll definitely tell you that you'll have a gig of data transfer speed, but it might not be, depending on where you are, that might not be as truthful as they might make it seem. They pretty much are your ISP is pretty much a snake oil salesman, your internet service provider. So they'll say that you'll have a gig of data transfer speed available in your area. In reality, you'll have like regular Ethernet. So always make sure that you run speed tests.
I like that over James Harden. I like that over James Harden.
Yo, mute your mic. Mute your mic, man. Mute your mic. We can hear you.
Yeah. But then these whichever way topic specs.
Man, how do you mute?
Tobias Harris and DeAndre Anthony, whatever his name is. Oh yeah.
Hey, AP, go to the
Yeah, I'm in the audio settings right now.
Draft picks like first round draft picks. We get Damian Lillard.
General.
That's a lot, though. That's a lot. But I'm like, we ain't got no bench. Yeah, that's the starting five. The sound good, but like, when niggas gotta take a rest, yeah. You gotta catch your level.
You audio for everybody except the host. All right, cool. Mic check, mic check.
we hear you.
All right, cool.
We hear you.
All right, cool. All right, cool. So yeah, definitely take a look at the Ethernet cable, the different cables, and or at least the speeds, because this is the type of Ethernet connection. So this is the different speed levels. So I should just put that at speed, but now we're going to get into the cables. So there's several different types of cables. Category 5E, Cat 5e cables are one of the most widely used Ethernet cables, and these are your common Ethernet cables that you'll see pretty much everywhere. They support up to a gig per second and are suitable for fast Ethernet and gigabit Ethernet networks. And for the most part, as you can see, a lot of them consist of 4 twisted pairs of copper wires. And when they say twisted pairs, that's basically what that means. Category 6, cables provide improved performance compared to Category 5E. They support higher data transfers up to 10 gigabits per second and offer better resistance to crosstalk and interference. So crosstalk is basically like back in the day, if cables were together, you could hear somebody talking on their phone. Like you could basically pick up interference from somebody else's phone if the cables are connected, if the cables are crossed because of different frequencies that are running through it. Cat 6A cables are an enhanced version of Cat 6, and as you can see, Cat 7 is obviously going to be an enhanced version of that. Fiber optic cables are as fast as we go right now over long distances. And the difference between fiber optic and these Ethernet cables is that data is transferred using the little wires, the copper wires in Ethernet cables. So the biggest difference is in fiber optics, it's basically sending light over through a reflective cable. So if you can kind of imagine with me a cable, which is like a big tube, and somebody sending a laser bouncing down to the different lasers bouncing down through that tube. That's basically what fiber optics is, and that those lasers are carrying information. So fiber optic cables use light signals to transmit data over long distances at high speeds. They're typically used for long-haul networking, backbone connections, and high-speed data transfer. Fiber optic cables offer bandwidth, immunity to electromagnetic interferences, and secure data transfer. It's important to note the different Ethernet cable types having various specifications, including maximum data transfer speeds, signal integrity, and distance limitations. So I'm not going to go over all those today. They are available here in this slide, and I will add them on the test. So just go through and just give them a glance, and I'll have some questions specific to different speeds of internet cables, because that is something that is on the CompTIA A+. They will ask you about, and it might only be like 1 or 2 questions, but they'll ask you. They'll ask you for sure. And as you can see here, you'll see the different types of cables. Cat 6, you can see the copper wires, the double twisted wires. Down on the Cat 6 UTP, you can get a good picture of it. Now we're going to hop into wireless communications. Wireless communications are today's communication. Everybody uses wireless communications when you're texting, when you're paying for things. There's always radio frequencies all around you. They're always working. So in today's increasingly connected world, wireless technologies have revolutionized the way we communicate, work, and interact with our devices, from Wi-Fi networks that provide seamless internet access to Bluetooth connections that enable wireless peripherals. Understanding and managing wireless connections is crucial for any IT professional. And that's true, because you're going to be troubleshooting a lot of Wi-Fi, a lot of VPN, a lot of Bluetooth. Usually you can just tell them to turn it off and turn it back on, though, honestly. If you're ever in doubt, tell them to reboot. It works like 80% of the time. Wi-Fi is a wireless networking technology that allows devices to connect to a network without the need for physical cables. So you won't need your Ethernet cable if you're connecting over Wi-Fi. You'll just be able to connect through your network adapter on your computer. And here we have the different Wi-Fi types and a little bit about their history. And we're not going to go too far into depth. Just know about 802.11b and 802.11a. 802.11a operates in the 5 gigahertz frequency bandwidth and offers a maximum data transfer rate of 54 megabits per second. It provides faster speeds and reduced interface compared to 802.11b. However, due to shorter range and limited capability, it is less commonly used today. And 802.11b was one of the earliest Wi-Fi standards introduced. It operates in 2.4 gigahertz frequency band and offers a maximum data transfer rate of 11 megabits per second. While it's been largely phased out by newer standards, some legacy devices may still use the standard. And then as you go down the list, usually in tech, it sounds crazy, but if you just use common sense, sometimes you can narrow down a lot of these questions when it comes to these tests, because a lot of it is kind of common sense. So as you see 802.11b or 802.11a, as different standards come into place, they add like more numbers or more letters, or they'll add a subsequent number or a, so it'll be like A will be the earliest version and then B will be the next version, or vice versa. So keep that in mind when you're taking these tests and they ask you about a certain version of something. Just know that whatever it has, this isn't just a standard, but in my opinion, this is something that I've always, it's something that I've seen, a trend that I've seen pop up. People just like to add numbers and letters to things the newer they get. Bluetooth, everybody knows about Bluetooth from their headphones or from different things that you'll use to pair, like speakers. Bluetooth is a short-range wireless technology. Emphasis on short, because when you're connecting to Bluetooth is going to pick up the connection that's closest to it. So keep that in mind when you're talking about connecting with Bluetooth. So like headphones, speakers, keyboards, and mobile devices to a computer or other devices, Bluetooth covers versions, pairing process, and troubleshooting Bluetooth connections. It's going to be important moving forward, because everybody has wireless keyboards and mouses nowadays. Everybody has wireless headphones nowadays, and troubleshooting those connections, a lot of times you could just turn it off, turn it back on. A lot of these Bluetooth applications have a lot of these Bluetooth devices have applications that support them and that they can connect through. So definitely utilizing the online resource as well. So if you're working with a Bluetooth device and you don't necessarily know what it is or how it works, try to see if there's an online resource that you can connect the device to through like a dashboard or something online. NFC, near field communication. This is how you pay for things with your phone. If you've ever done Apple Pay or like Quick Pay or anything, or Zelle, you can do anything with the wallet nowadays. With the Apple Wallet, you can pay with your credit card, debit card, anything. So NFC is another short-range wireless communication that enables the exchange of data between devices in close proximity. And this is not like Bluetooth. Bluetooth, you can be within a couple feet, and if you're the closest person within a couple feet, it'll connect. But with near field communication, you have to be within a few centimeters. You have to be really close. It operates at a frequency of 13.56 megahertz. NFC is commonly used for contactless payment, mobile device pairing, and data transfers between smartphones, tablets, and other NFC-enabled devices. RFID, this is what you'll use if you have like a key card for a door, or if you have like a scanner, if you work in like a warehouse. RFID is technology that uses radio waves to identify and track objects. It consists of tags, also known as RFID tags or transponders, and readers. RFID tags contain electronically stored information that can be read wirelessly by RFID readers. The frequency used by RFID systems can vary depending on the application and region, but common frequencies include low frequency, high frequency, and ultra high frequency. And we have, they're pretty self-explanatory. Make sure that you look over the different frequencies that they operate at. Between so for low frequency, you're between 125 and 134 kilohertz. And with a high frequency RFID, you're above 13.56 megahertz. and just know what they're used for. This is good information to go over because high frequency, just know the difference between what high frequency and low frequency are used for. High frequency is used for payment systems, inventory tracking, and library management. And low frequency or ultra high frequency operates at frequencies between 860 and 960 megahertz and is used for applications requiring longer read ranges such as supply chain management and asset tracking. So if you work in a warehouse, you're probably familiar with RFID. If you work at a job where they require you to have a badge, you're familiar with RFID. These are all common use cases for RFID. Retail logistics are huge. The PSU, or the power supply unit, is something we kind of missed out on when we were talking about building our computer, and this is basically what controls the current coming into your device. These are different aspects of the PSU, so power conversion, power distribution, wattage and power ratings, connectors. It connects all of your devices on your motherboard. It doesn't connect the device on your motherboard, but it provides power connectors to deliver power to different components, basically. This is what a PSU looks like in most common PCs. The one on the left looks a little bit newer than the one on the right. The one on the right, you can look at the connection type and see that it might be a little bit older. Power supply architecture just basically refers to the design and structure of the power supply unit. It includes circuitry, components, and technologies used to convert and deliver electrical power to a computer system or other electronic devices. Power supply architectures can vary based on factors such as efficiency, regulation, noise suppression, and form factors. The biggest thing to know about the PSU is just that it powers the computer. You can't do anything without power. So if your computer's not turning on, there's no noises, no lights, nothing, there could be a power issue. Voltage or force, also known as electrical potential difference, is the measure of electrical potential energy per unit charge. It represents the force or pressure that pushes electrical charges through a circuit. Voltage is measured in volts and is denoted by the symbol V. It determines the intensity of the electric field and influences the flow of current in a circuit. So this is basically the measurement of the force of the voltage that's going through the circuit. I mean, not the force of the electricity going through the circuit. So amperage or amp, current. Amps, also refers to as current, is the flow of electrical charge in the circuit. It measures the rate at which electrical charges move past a given point. Amperage is measured in amperes and is denoted by the symbol I. Current is influenced by voltage and resistance in a circuit and is governed by Ohm's law. Then we'll get into ohms. Resistance is the opposition to the flow of electric current in a circuit. It represents the restriction or impedance that a material or component presents to the movement of electrons. Resistance is measured in ohms and is denoted by the symbol R. It determines the amount of voltage required to produce a specific current through a circuit and is also a key factor in determining power dissipation. So we'll go over this a little bit more as we move along, but it's not super important. It is super important because it is power, but to my recollection, there wasn't as many questions on this. There were about 1 or 2 questions. Watts, which is work, represent the measure of electrical power in a circuit. It quantifies the rate at which work is done or energy is transferred. Watts are calculated by multiplying voltage by current and are denoted by the symbol W. Watts indicate the amount of power consumed or generated by electrical system or device. Okay, alternating current, this is important, is an electric current that periodically changes directions, and in AC current, the flow of electrical charges traverses directions at regular intervals. AC is a standard form of power transmission that is used in most household and commercial electrical systems. Direct current is an electric current that flows in a single direction. In a DC circuit, the flow of electrical charges remains constant with time. DC power is commonly used in batteries, electronic devices, and specific applications where a steady and unidirectional flow of current is required. So basically, small toys, appliances, handheld devices, mobile powering like batteries. Power supply connectors are the physical interfaces or socket used to connect the power supply unit to various components within a computer system. These connectors deliver power to the motherboard, graphics card, drives, and other peripherals. Examples of the power supply connectors include ATX, EPS, SATA, PCIe, and Molex connectors, and we went over all of those, and most of them transfer. So ATX motherboard, PCIe is on a piece on your motherboard, the express bus basically that transfers data. SATA is your hardware that's in your hard drive that needs power. So this is basically everything that the power connector touches. Power supply installation, we'll go over that a little bit more later on in the unit. Power supply safety, so it encompasses the precautions and guidelines to be followed when worked with power supplies to ensure personal safety and prevent electrical hazard. This includes practices such as proper grounding, make sure that you have some metal touching the ground, avoiding exposure to live circuits, handling electrical components safely, and adhering to safety standards and regulations. So anytime you're going to work on a device, anytime you're going to work on a device or a computer, a laptop, anything, before you open it up, you want to disconnect the power. Like 101, disconnect the power before you start working on your computer. Turn it off, your laptop, anything. When you flip it over, when you open it up, especially if you're working directly with the PSU or you're handling anything in there, you want to turn it off. Turn it on for testing, and make sure that you also, so a lot of other power supply safety and just computer safety in general, make sure that your circuits are not exposed, make sure your motherboard isn't exposed, make sure it's not getting dusty because it can catch on fire, make sure that there are no, there's no foam or plastic, like thin plastic that carries static. Make sure that you're not carrying any static because static can fry memory. So just make sure that you're using common sense practices when it comes to operating and maintaining computers and working on computers and working on any of this hardware. The system BIOS, short for basic input and output system, is firmware. Firmware is not hardware. It's not something that you can touch, but it's software that basically controls your hardware. So it's software that it'll fix like bugs and little things that are going on with your device that so definitely, like, companies will release firmware every year. The cameras that I'm using, the computers that basically the camera will come with a new firmware update. Anything that's not software based, firmware update. Software based hardware maintenance. Basically that's what firmware is. Yeah, software based hardware maintenance. So your BIOS, it resides on the computer's motherboard. It's responsible for initializing and configuring essential hardware components during the boot process and providing a basic level of input-output functionality for the computer system. So you can basically boot into your BIOS. Like if you turn your computer on and before it boots up to like the Windows screen, if you have Windows, press F12 and it'll boot straight into your settings and you can go into your BIOS. You can control your BIOS. All right. Oh, it doesn't look like I muted everybody. Give me a second here, guys. Let me look at my meeting controls. Anyway. All right, so yeah, you can look over the different, what the BIOS does, and this is basically It powers on post. So during the system startup, the BIOS performs a series of diagnostic tests. This is called post or power on self test. This process checks the integrity of the essential hardware components such as the CPU, the RAM, storage devices, and other critical system components. If any issues are detected, error codes or messages may be displayed. Hardware initialization, so that's basically just opening up and configuring your hardware. The system BIOS initializes and configures various hardware components. And it's common across everything: the CPU, the memory, expansion cards, input, output devices, and ensures that these components are properly recognized, initialized, and made accessible to the operating system. BIOS configuration. The system BIOS provides access to a user's interface called the BIOS Setup Utility or BIOS Configuration Utility. This interface allows users to modify settings in the system and parameters such as boot order, date and time, device configuration, and security options. And this is what I was talking about when I said you can boot into your BIOS settings. These settings are stored in non-volatile memory and are retained even when the computer is powered off. Remember that term, non-volatile, volatile? Well, if you didn't watch Tuesday yet, definitely watch Tuesday. You'll learn the difference between volatile and non-volatile memory. And I can just tell you right now, volatile memory is when it's basically your RAM. So when you lose power to your device, your RAM, your random access memory, all that memory is lost. When you boot your device back up, the only information that is saved is information that's saved on non-volatile devices, like your hard drive and SSD is non-volatile, a hard disk is non-volatile, DVD is non-volatile. These are all examples of non-volatile memory. And so a lot of these, if you didn't get a chance to look at Tuesday, a lot of the stuff is kind of coming up again here on day 3. It all kind of builds on itself. So definitely go back and check that out if you haven't. Boot process control. The system BIOS initiates the boot process by locating and loading the operating system from the specified boot device. And you can control that as well. Once you turn your computer on, just hit F12 and it'll take you to your system settings. It determines the boot order, which defines the sequence in which the system searches for a bootable device. Hard drive, optical drive, USB drive to start the operating system. So if you wanted to run an operating system from a disk, like a flash drive, there are some operating systems like Linux that will fit on most operating systems will fit on a USB. All operating systems will fit on a USB, but you can run Linux directly from the USB. You can run Windows directly from the USB. You can run Mac OS from a USB. But for the most part, Macs come with their own operating system, unless you get like a virtual machine where you can run something else like, Kali or Windows. But that's later on in the course. We'll talk about that. Low-level input-output operations. The system BIOS provides basic input-output services for hardware devices before the operating system takes control. It enables communication with devices such as keyboards, mice, storage devices, and display interfaces, allowing the system to interact with these devices during the boot process. System security and firmware updates. The system BIOS may include security features such as password protection and secure boot options to enhance system security. Additional BIOS updates can be applied to improve capabilities, compatibilities, fix bugs, or add new features to the firmware. UEFI is just another system that boots in your BIOS. It's important to note that modern systems often use UEFI, and we kind of talked about this on day 1, the difference between UEFI and legacy. And both of them are traditional BIOS settings. The CMOS battery. Now this is a battery on your motherboard. It refers to the technology used to create the small amount of memory on the motherboard known as the CMOS memory or CMOS RAM. This memory stores system information, including BIOS settings, date and time, hardware configuration, and power on defaults. So this is basically what controls your boot. This is the battery outside of your actual PSU that powers your device on. This memory is what controls those settings and the date and time and hardware configurations outside of your BIOS settings. So your BIOS is the actual settings, and this is the actual the BIOS is the firmware, and this is the actual physical piece that controls that. It's like a brain within a brain within a brain in your computer. Updating the BIOS, you got to be careful updating the BIOS. An incorrect update, and if it fails, it could render your system inoperable. Most of the time, you're not going to be updating the BIOS as a system analyst. You might have to update the BIOS as a system administrator. I've had to update the BIOS at past jobs, but not really, not often, rarely ever. So now we're going to get into monitors and displays, and we're moving along here. We only have about half of this left, and the display devices are monitors. Everybody pretty much knows what a monitor is. It's something that you connect to your computer. It's an output device, so it connects to your computer and it outputs information. The viewing size refers to diagonal measurements of the display screen. So the viewing size is like 14. If you ever hear somebody talk about a 14-inch monitor or a 13-inch monitor, they're talking about the viewing size. The resolution is self-explanatory. It refers to the number of pixels displayed on the screen, typically denoted by the width and height in the pixels. It determines the level of detail and sharpness that can be displayed on the screen. Higher resolutions offer more pixels, resulting in clearer and more detailed images. So whenever you're on YouTube, if you ever click on that little gear in the bottom right-hand corner, you can control your resolution. You can go from 144p to like 4K. So and those are basically just the amount of pixels that are in the height and the width of your display. Common monitor resolutions, we kind of just went over this. Full or HD 1080p 1920 by 1080. We've got 2K or Quad HD. We've got 4K, Ultra HD, and 5K. 5K is used in high-end monitors, offers even greater detail and clarity. Most things, like when you're streaming, it's going to be knocked down in most cases to 720p, which is still HD, but it's not full HD. Streaming in 4K, you'll fry everything in your house. Your contrast ratio is basically the difference between how much detail in your blacks you get. So contrast ratio represents the difference between the brightest and the darkest parts of an image displayed on the screen. It measures the ability of a display to show a wide range of colors and shades. A higher contrast ratio generally indicates a more vibrant and dynamic image. And down to the right, you can see the different contrast ratios. Dot pitch refers to the distance between the individual pixels on the display, and is typically measured in millimeters. Cathode ray tubes, these are those old big booty TVs. As you can see, this thick TV down to the right, you can see the tube inside of it. CRTs were an older technology used in traditional bulky monitors. They used an electron beam to display images on a phosphor-coated screen. However, CRT displays have largely been replaced by newer technologies such as LCD and LED. If you see one of these in somebody's house, man, they down bad. Shoot them my course. Monitor scanning. Monitor scanning refers to the process of drawing or refreshing the display screen. In older CRT displays, this involved the electron beam moving across the screen line by line to display the image. Modern displays, such as LCDs, use different methods for image rendering. And if you've ever seen like an old monitor where the scan is like a line just going down your whole computer horizontally, and it's like it's drawing on your computer. You can literally see it scanning your computer. Degaussing, if you guys are familiar with like Gaussian blur, if you've ever, well, I mean, I guess it's on Instagram too, they have the blur feature. Degaussing is a process used to demagnetize the screen of a CRT monitor. It helps eliminate color distortion caused by magnetic fields, ensuring a more accurate display. So you can see this picture is distorted. You would use degaussing to get this back back to its original form. LCD, or liquid crystal display, is a common display technology commonly used in modern and flat panel TVs. It utilizes liquid crystals that can be controlled to selectively block or allow light to pass through, creating the image. LCD displays are thin, lightweight, and energy efficient. As you can see here, the liquid crystal, the electrodes, color filtering. It has a bunch of different layers on it. But the main thing to remember is that it has liquid crystals that are utilized, and that light passes through, and it's either blocked or it's passed through. Multi-monitor configuration. This is what most of your work setups probably look like. If you work from home, if you're working a remote job, you'll have a docking station that connects two screens together. Projectors project screens on surfaces. They're commonly used in presentations, classrooms, and home theaters. Everybody knows what a projector is. Video graphic interfaces. Okay, so these are the different types of ports for your display cables. So for your display, as you can see, most people are probably familiar with an HDMI. There's HDMI, that's the newer version. DisplayPort is fairly new. VGA is the deprecated older supported port. DVI is older. Thunderport is relatively new, at least within the last quarter century. Component video and composite video are both almost fairly obsolete unless you're using some old equipment, maybe some old production equipment. That's how people used to be able to hook up the old gaming systems. If you remember, the old Xbox used to have the Xbox 360 was probably the last thing I saw with a composite video attachment or cables that came with it. Display cables, we have the different display cables here, and you guys can go back and look at them. The main ones are HDMI and DisplayPort and Thunderbolt. Those are the main ones that you'll see today. Customized systems. Customized systems refers to computer systems that are built or configured to meet specific requirements or preferences of an individual organization. So this is just a custom build. Some key aspects of a customized system is performance optimization, form factor, and case design. So basically what's compatible with your motherboard. You know, you always want to make sure that you get a case that is big enough for everything and can hold everything comfortably. Performance optimization is basically just updating your RAM, updating your CPU or graphics cards, things like that. Software configurations are updating your customized software. Software configurations are customizing your systems, may involve the installation and configuration of specific software or operating systems tailored to the user's requirement. So a big thing about software configuration, most organizations deploy some form of software configuration whenever they build a new laptop for a new employee. It's called an image. Just keep that in mind for future reference. Whenever you image a computer, you're basically customizing the software configuration for that computer. And every organization has its own image with its own proprietary apps on it, so that you don't have to go in and download these things individually on everybody's computer every time we onboard or terminate somebody. Specialized features. Customized systems can incorporate specialized features based on the user's needs. This may include additional ports, expansion slots, cooling systems, or connectivity options tailored to specific usage scenarios or industry requirements. Testing and quality assurance. Customized systems often undergo rigorous testing and quality assurance procedures to ensure proper functionality, stability, and compatibility. This includes verifying the compatibility of hardware components, stress testing the system, and ensuring optimal cooling and power management. So definitely always test your system. A lot of times when people make these custom systems, they don't take into account what it's going to take to maintain it, what it's going to take to make sure that these pieces and these parts are running efficiently for as long as they can before failure. A lot of times you can take years off of devices by storing them in places where there's a lot of dust, where the temperature doesn't necessarily meet the need for their optimum operational needs. CAD and CAM is software, and this is basically the software. CAD software is what engineers use to basically create 3D renderings of different new technologies that they want to test. So CAD stands for computer aided design, and CAM stands for computer aided manufacturing. It refers to the use of the computer software and systems to design and manufacture products. CAD CAM systems assist in creating 2D or 3D designs, simulating processes, and generating instructions for manufacturing or prototyping. So just remember that's a software option where you can use the computer to simulate things that you would want to engineer and design in real life, but might not have the resources or might not want to spend the time making it in real time, because it takes a long time to make something, to build something up. You got to source materials, then you have to find documentation that kind of supports what you're trying to create and helps you along the way. It's easier to just make it as a 3D rendering, test it out, and then send it off for prototyping. Audio-visual editing station. An audio-visual editing station is a workstation or a computer system equipped with specialized software and hardware for editing and manipulating audio and visual content. It is used in multimedia production, video editing, sound design, and other creative endeavors. Some key softwares that you would use for audio-visual editing in your station would be like DaVinci, Premiere Pro, Final Cut, Avid, this is any setup where you're using. And the thing about an audio-visual setup is you have to make sure that you have a lot of RAM on your computer. RAM is a big thing when it comes to editing video. You should always look for a computer with at least 32 to 64 gigabytes of RAM. And you should look for a processor that is relatively new. It doesn't have to be, it's not as important as your RAM. Your RAM is huge. Your graphic card, definitely huge. Make sure that you get a newer graphic card because you're gonna need that for displaying different things you're trying to edit. When you're editing, you wanna be able to play back that video in real time when you're editing. So that comes from having a lot of RAM and being able to even display the information that you're inputting into the software. You need a good graphics card to really represent that accurately. Really give you the picture that's going to be, to give the picture that's the closest to what is going to be output for the customer. A thick versus a thin client. A thick client refers to a computer or workstation. I promise, guys, just bear with me. We have a couple more slides. A thick client refers to a computer state or a workstation that has a significant amount of processing power and storage capacity locally. It can perform tasks and run applications independently of network resources. Thick clients are often used in environments where local processing and data storage are necessary, such as designing workstations or software development systems. A thin client, in the context of computing, refers to a lightweight, minimalistic computer or device that relies on a server or central host for most of its processing and storage capabilities. Unlike traditional desktop computers or thin clients have limited local processing power, storage capacity, and software capabilities. A virtualization workstation is a computer system optimized for virtualization technology. Virtualization is just, think about if you have a computer is a piece of hardware. If you virtualize a computer, you make a virtual machine that will simulate a computer. So virtualization is just creating virtual instances of real world devices. So you can create like a virtual switch, you can create not a virtual switch, you can do like virtual computers, you can do virtual servers, you can do a bunch of things virtually. You can pretty much, any device that you can use physically, you can pretty much virtualize. It is capable of running multiple virtual machines simultaneously, allowing for efficient resource utilization and isolation of operating systems or applications. Virtualization workstations are commonly used in IT environments for testing, development, and server consolidation purposes. So when it says for allowing for efficient resource utilization, when you're running a virtual machine on your computer, basically what it does, so I have my laptop and I have a virtual machine running on my laptop. So I have another computer that runs Windows on my laptop. That virtual machine will take resources, real resources, from the computing power of my laptop. So when I'm using my laptop and my virtual machine at the same time, things are going to move slow. When things are just going to move slow. Like when you have a bunch of stuff running locally and you have a bunch of stuff running on your virtual machine, anytime you have just a bunch of stuff running in general, your computer is going to be moving slow. A lot of times people are like, why is my computer moving slow? It's like you have 30 tabs open. Why do you think your computer's moving slow? Maybe close your browser and go to Task Manager and close a few processes that may be running in the background that you don't need, like applications and certain things. All of these things, anytime you're doing something on your computer, it's taking resources from your RAM, from your CPU. It's taking resources. Your gaming system is huge. We kind of covered this already. Graphic cards are big for gaming systems. You want a lot of RAM, but you also want the most advanced graphic card and cooling system, because when you are playing games, you're playing games for hours on ends, and you need something that's going to handle the demand of the requirements of the game, because your computer is going to get hot. So always think, when you're thinking gaming system, think graphic cards. Home theater systems refer to a setup that creates a theater-like audio and visual experience in a home setting. It often includes a large screen or projector, surround sound speakers, an audio-video receiver, and various multimedia devices for watching movies, streaming content, or playing games. It's pretty self-explanatory. You have an audio system linked up to a video system, and that is your home theater. A home server is a computer system configured to provide services and resources within a home network. It can function as a central storage hub, media server, file server, or perform other tasks to enhance home network functionality and facilitate data sharing amongst connected devices. So basically, a home server is just a computer that you leave on all the time. It's always running, and you can connect to it and store data on it, and people can go and connect to your server and get files off of it or perform other tasks. And that wraps it up for day 3 of our week 2. So day 2 of week 2, day 3 of our overall course. And we covered a lot of information. We have covered a lot of information. This is about 156 slides of info. On Friday, I'll have a test available for you guys. And the test will kind of help you if you haven't been following along. It'll help you narrow down key parts of the course that I need to reiterate over and over again that are important, because they're gonna be directly on the test. So I'll have something about 10-15 questions available for you guys tomorrow some point during the day. And it's not like school where it's like you grade it and you fail a class. If you do bad on the test, then that just means that you need to go back through these slides and try to find pertinent information, or do your own research and go online. I mean, it will be easier to come to these slides because all the information is right here. But yeah, so that's it for today. I appreciate you guys sticking around. It's 7:45. We kind of got a late start, but we still ran over. So we ran over a little bit. But if you guys have any questions, just let me know. If you want me to go over something in depth while you still got me, that's cool. If not, just give me a call on the side. I'm always available. Any of you guys can give me a call. Don't think because you don't know me directly or we haven't had a conversation that you can't call me and just ask about anything. Ask about, people called me pretty much every day this week about different things, the job market, different things about the curriculum. And so I enjoy all that, man. Definitely interact with me. Definitely use me as a resource, because that's what I'm here for. So does anybody have any questions?
How much you would charge?
No, I'm good.
For that?
How much with what?
No, I said I'm good. I'm good.
No, somebody else said something. Oh, or that was you. Somebody in the
Yeah, that was
background.
me.
Okay, yeah. So shoot, if that's it, then yeah, we can go ahead and wrap this thing up. I appreciate you for hopping on. Let me stop sharing here. I appreciate everybody for hopping on. How many people we got in here today? Okay. We got a good amount of people in here today. Make sure you share the information with everybody. The info's in the chat. With any friends that you have, any homies, relatives that keep asking you to put them on something, go ahead and send them the links to our videos, and I'll go ahead and chop these videos up later on down the road and make it more palatable, because I know nobody trying to watch a 50-minute video. That's hard to sit through. So so I will be chopping these down so everybody can just kind of go through, and I'll also provide the links to this slideshow here, as well as like our syllabus and different tests that I make throughout the course to kind of help you guys study. So if that's it, I'm gonna go ahead and hop off. I appreciate you guys, and you all have a great night.
Appreciate you.
Yep.
Thank you, mate.